Hello, welcome to day 2. We are going to introduce our new function called the exponential function and compare it to a couple of functions that we've worked with before. So a reminder of our norms, just be positive, listen to the video, be present. It's going to be a short one. Okay, so we today are going to identify the difference between linear, we've worked on linear before, quadratic, and now our new exponential functions. Okay, so here's linear. Linear means straight line, and every single one of these functions are a straight line. The way to recognize a linear function is in one of the forms. Usually we see it in this form, y equals mx plus b. Notice there's no exponents, or it's x to the first power, which gives you a linear function. The other function that we've worked with quite a bit is quadratic functions. The way to recognize a quadratic is this guy right here, this x squared. Anything to the squared power is quadratic, and it produces this U shape called a parabola. I don't know why I'm highlighting in gray. There we go. It's called a parabola. So of everything that's on this slide, I need you to remember that it's when you have an x squared, it graphs a parabola, which is this U shape, either open up or open down. That's quadratic. Okay. Next would be the exponential function. So the way you know you have an exponential function is your variable is now in the exponent. Okay, there's two different kinds of exponential functions. There is growth and there is decay, and we'll discuss the difference between the two of those. It also has a horizontal asymptote, and we'll discuss why that's the case. So here are our new functions, exponential growth and exponential decay. So an exponential growth function, put some arrows on the end, as your x values get bigger, your y values get bigger. Okay, that means that the growth factor is bigger than 1. So you can see that here. This base number has to be bigger than 1. So this could be y equals 2 to the x. So 2 to the first, 2 to the second, 2 to the third. As your exponents get bigger, your y values get bigger. Okay, decay, as my x, and I need arrows on the ends of these, as my x values get bigger, my y values get smaller. So a base that would give you decay is half. If you take half and then take it to the second power and to the third power, you keep multiplying by half, you keep cutting things in half. You're decaying, okay? And that means that your b is between 0 and 1. Okay, so let's look at growth a little more. So whenever I graph exponential functions, I like to make a table. And we're graphing 2 to the x, and I do a few negative numbers, 0, and positive numbers. So this is going to go back to the beginning of the semester. What is 2 to the negative 2? Well, I know that 2 to the positive 2 is 4. 2 to the negative 2 would give me a fraction of 1/4. So I'm going to put that point on this graph. Negative 2, 1/4. And then 2 to the negative 1 would give you 1/2, half. 2 to the 0 is 1. All exponential functions go through 0, 1. That is always a point on unless there's a transformation. All exponential functions go through 2, 1. 0, 1. And then 2 to the first is 2. And 2 squared is 4. And 2 to the third is 8, and 2 to the fourth is 16. So you're multiplying by 2 over and over and over again, and it produces this graph, 2 to the x. Okay, the domain is all real numbers, and the range is 0 to infinity. Why is 0 not in brackets? Well, as you go in this direction, I'm going to go right over my table. As I go this direction, I'm getting closer and closer and closer and closer to 0, but I'm never crossing it. I'm getting infinitely close, but not crossing it. So I'm going to have, I'll change the color, I'm going to have a horizontal asymptote here on the x-axis. It's going to get infinitely close to it without crossing. Okay. Domain, oops. For exponential decay, let's do another -2 to +2. 1/2 to the -2. Remember, 2 squared is 4. That negative is going to flip the 1/2. So instead of 1/4, it's going to be 4 over 1. So that would be right about here. 1/2 to the -1 flips half, and you get 2. 1/2 to the 0. Remember, all exponential functions go through 0, 1. 1/2 to the first. This table's a little wonky. You get 1/2. 1/2 to the second power. You get a 4th. And then an 1/8, and then a 16th, and then 1/32. If you continue to cut in half, you'll get really, really close to 0 without crossing. So we have a horizontal asymptote here. Growth and decay both have a horizontal asymptote. They both go through this point, 0, 1. This is decay because the base is between 0 and 1. Okay. So are you able to figure out which ones are which ones are exponential, which ones are linear, and which ones are quadratic? So go ahead and pause and write down your guesses, and then open up this slide again and see if you could get the same things. If you're not sure, just follow along with me. So linear means line. Anything that's a straight line, linear. Okay. Quadratic, that's a U shape. So this would be quadratic. This would be quadratic. And this guy would be quadratic. Okay. Exponential, we've got growth or decay. This, see my horizontal asymptote, this would be exponential. Here, my horizontal asymptote's up here. These were both growth, and this one's decay. Horizontal asymptote here. So that's exponential decay. So we've gotten to the homework portion. I'm going to actually change this. So there is no worksheet. You are heading to the Schoology quiz called Exit Ticket, where you are discussing exponential, quadratic, and linear, which one's which. Okay, so you do that first. That will open up a Desmos homework. You have a code for the Desmos homework. Complete it. Make sure you put your name on it. Otherwise, I won't know that it was you that completed it. And I'm going to give that one the formative grade. Fingers crossed it all works. Good luck, guys.